Hello, my name is Austin Garcia. This is my project 1 for location analytics. So the question that I asked was, which areas in Tennessee experience the highest burden of stroke cases, and how does the stroke rate vary across different population sizes at the census tract level? Uh, so the first thing that I had to do was the Excel file that I had information on all states, and that was too much for my computer. So I had to manually go in um, to Excel and then copy the data that was relevant to Tennessee, paste that into a separate Excel document in order for my computer to load in the CSV file. So I had to import the libraries necessary. This is me reading in the CSV. Mention it here, but I did change the name just to make it a little more understandable. And so here is my first map that I created. We see map. So the health outcomes was one of the columns, and from a health outcome there was strokes, the possibility outcome of a stroke. So this is a map of stroke health outcomes in Tennessee. I mentioned this in my reflection, but I thought for sure Davidson County would be the most, but right here where the highest density is clearly Shelby County. So Shelby County actually beat out Davidson County. So in the previous block of code, this is the list of changes I made to the data. I filtered the data so that only stroke from the column measure ID was used. The next change I had to do was with the creation of another column. I created a new column, total stroke cases, which is the total number of stroke cases for each location. This is calculated by multiplying the data value, percentage of stroke cases, by the total population, then dividing by 100 to get the actual number of cases. Then I split the geolocation string into separate longitude and latitude columns using string extraction, then converted the longitude and latitude into numeric data types. The Excel file does not include geometry columns, so I created a geometry column using the shapely geometry.point method, which combines the longitude and latitude in geographic point objects. Next, I converted the Excel document into a geodata frame. I set the coordinate system since the Excel file did not contain one. Lastly, I saved the file as a geo package for the purposes of submission. This is the county FIPS column that actually has the census tract. So I was making sure that in my geodata frame that was an attribute in it. And then this is the next plot that I made. This one is different as it has like the rates, which again, Shelby County is higher than everything. So here's what some of the assumptions that I made during this project. Throughout the project, several assumptions are made to ensure the data can be effectively analyzed and visualized. First assumption was that data valve column accurately represented the percentage of individuals affected by stroke within each census tract, which allowed me to calculate the total number of stroke cases by multiplying the percentage by the total population. Additionally, I relied on the accuracy of the geolocation coordinates, assuming that the latitude and longitude provided correspond to the correct geographic center or representative point of each census tract, since the shapefile could not be loaded. I used the county FIPS and location ID columns to represent census tract level data, assuming that identifiers provided the necessary geographic linkage for the analysis. I also set the coordinate reference system to WGS84, assuming that this was the correct system for analyzing and mapping geospatial data in Tennessee. I also assumed the total population figures were up to date and accurately reflected the population. So for the analysis part, the first map visualizes the total number of stroke cases across Tennessee at the census tract level by showing the raw number of stroke cases in each tract. This map highlights areas with the highest and lowest amounts of strokes. This approach provides a clear understanding of how stroke incidences are distributed geographically. This map was selected because it offers a direct visualization of the areas with the most significant stroke burdens, making it useful for resource allocation and predictive modeling. The second map focuses on stroke rate, showing the percentage of the population affected by stroke within each census tract. This map highlights tracts where the proportion of stroke sufferers is high, even if the total population is small. This map is helpful for focusing efforts on regions where stroke may be more common relative to the local population, which can help guide preventative measure and early intervention. Together, these two maps offer complementary insights. One focuses on the overall burden of stroke, while the other highlights areas heightened relative risk, helping optimize stroke prevention strategies across Tennessee. And that is my project.